to Dr. Maisara and my fellow friends. My name is SITI NURJAZILAH binti Mohamad SUKRI. So, in this video, we are going to talk about high performance liquid chromatography or HPLC. Now, let me introduce our team members first. And these are the agenda that will be covered in this video. HPLC or high performance liquid chromatography is an analytical technique that used to separate, identify or quantify each component in a mixture. The mixture is separated using the basic principle of column chromatography and then identified and measured using spectroscopy. HPLC is a powerful tool in analysis. It produces high performance and high speed compared to the traditional column chromatography because of the forcibly pumped mobile phase. In fact, HPLC is a significant improved version of column chromatography. Instead of allowing a solvent to flow through a column under gravity, it is pushed through a high pressure up to 1400 atmosphere. Okay, now we proceed to the sample preparation. The goal of sample preparation in HPLC analysis is to produce homogeneous, repeatable sample that is appropriate for injection onto the column. The objective of sample preparation, including making sure it is interference-free, won't harm the column, and works with the HPLC process. The type of sample can be divided into organic and inorganic categories. These can be further subdivided into solid, liquid, gases, and semi-solid like gels or cream. Gaseous samples are often processed by GC. However, those that are fragile, thermally unstable, or likely to absorb are better handled by HPLC. In comparison to gases or solid, liquids are simpler to prepare for HPLC. It is necessary to process solids and semi-solid initially by lowering the particle size of the sample. Grinding, milling, chopping, and blending are the techniques that used for reducing particle size. This enables more precision and value. How is the sample introduced into HPLC? A liquid sample is injected into a mobile phase solvent stream that is passing through a stationary phase or separation medium field column. As the sample components travel through the column, a process known as differential migration separates them from one another.
Next is components in HPLC. Actually, there are 5 main components of HPLC, starting from the top, which are solvent, which act as a mobile phase that helps to induce the motion and interaction required for the separation of particles. Next is a pump that helps to maintain a constant flow of mobile phase through the HPLC system. Other than that, the injector to inject the samples to be analyzed into the HPLC system. Next is the column, which acts as a stationary phase that constrains many of the components in a mixture, making them move slower than the mobile phase. And lastly, at the bottom is the detector, which will detect components of mixture being emitted from the chromatography column. The previous slide is a picture of HPLC from the outside. However, in this slide, it is shown the schematic diagram of HPLC to help us to see the components of HPLC more clearly, starting from mobile phase, pump, injector, column, and lastly detector. Next is principle of HPLC. The principle in normal phase mode is separation, meanwhile reverse phase mode is adsorption. Both of these actually depending on the stationary phase. If the stationary phase is solid principle, it will be based on adsorption chromatography. Meanwhile, if the stationary phase is liquid principle, it will be based on partition or separation chromatography. The separation technique involves the injection of a mobile phase, which is a small volume of liquid sample to be transported along the packed tube, which is known as column, by a liquid by high pressure delivered by pump. They then travel according to their relative affinity towards the stationary phase. The component which has more affinity towards the adsorbent travels slower. Meanwhile, the component which has less affinity towards the stationary phase travels faster. Since these two components do not have the same affinity towards the stationary phase, this causes the components to be separated. These separated components are then detected at the exit of column by a flow-through device or known as detector that measure their amount.
The technique used for HPLC is separation technique. There are 2 modes of separation, which are reverse phase HPLC or ultra high performance liquid chromatography UHPLC. Reverse phase chromatography or RPC is a liquid chromatography technique involving the separation of molecules based on hydrophobic interaction between the solid molecules in the mobile phase and the ligands attached to the stationary phase. In RPC, the stationary phase is a non-polar phase while the mobile phase is a polar organic solvent. alkyl or aromatic ligands are covalently bound to the stationary phase to give a hydrophobic surface. The mobile phase passing over the hydrophobic stationary phase is a polar solvent containing the solutes. Ultra-high performance liquid chromatography is used to identify, quantify, and separate the components of a mixture of the complicated samples such as botanical, dietary supplements, and biological samples by using high pressure to push solvents through the column. In UHPLC, particle size below 2 micrometer can be used, serving a better separation. These smaller particles require higher pump pressure, making this technique very efficient with fast analysis and high resolutions. Qualitative analysis. The purpose of qualitative analysis is to answer the question, what is in the sample? Two discrete situations reside for qualitative analysis. Firstly, the sample components are known and peaks within the chromatogram need to be assigned to known components. Second, is the sample is complete unknown that we are trying to identify. Identification of a sample component is performed by comparing its retention time with that in a standard sample. Analyzing the HPLC collected components by IR or mass spectroscopy enables reliable qualitative analysis. Quantitative analysis. After we identify and integrated the peaks, the next step in the analysis is quantification. Quantification uses peak areas or heights to identify the concentration of a compound in the sample. There are two methods for quantification, which are the external and internal standards method, which both use a calibration curve. So what is calibration curve? Calibration curve is a graphical representation of the amount of response data for a single analyte or compound obtained from one or more calibration samples. The curve is created by injecting an aliquot of the calibration with the standard solution of known concentration and measuring the peak area obtained.
Next, I will present the applications of HPLC that are most widely applied. HPLC can be used in the following applications. In the clinical, HPLC provides a convenient and fast-analytical approach in quantification of drugs in body fluids to confirm the identity of a drug and provide quantitative result. Meanwhile, in the pharmaceuticals, as a quality control and shelf life of a synthetic drug product. For the environment, the detection of chemicals can be identified in the drinking water. It is likely to determine common inorganic anions in drinking water. Mostly, it is organic contaminants such as pharmaceuticals and pesticides in drinking water samples. In the forensic, HPLC will involve the analysis of textile dyes. Textile dyes have different dye classes such as reactive, passive, acid, direct, and disperse. The separation and identification of complex mixtures of natural and synthetic textile dyes using HPLC with diode array detection. Separation was carried out on a reverse phase column with acetonitrile phosphoric acid gradient elution. In industry, HPLC is applied in the stability of compounds in food products. Stability of a food item means how long that item can be stored without visible changes or a change in its taste or flavor. If a food item is kept under normal conditions, visible changes may occur. The changes may be physical or chemical. During research, HPLC is also useful for separation and isolation of components from natural samples from animals and plants. HPLC also has limitations such as the cost of generation of high pressure. High pressure imposes some constraints on instrumentation. Relatively, it has low flow rates, thus time-consuming its sluggish. These problems can be solutioned as to decrease the pressure and increase the flow rate for comparable resolution of analytes of HPLC perfusion chromatography. Next, increase the instrumentation that can withstand high pressure by considering cost economics for better resolution than HPLC UPLC. Since HPLC also is useful in the separation and analysis of low molecular weight biomolecules, it is not usually used for purification of complex polymers like proteins in active form. The reason is because some HPLC formats like reverse phase chromatography need organic solvents which denature proteins. Although large capacity HPLC columns are available, they are expensive, so the problem can be a solution as development of another format for biopolymers, FPLC. HPLC has its advantages: fast and efficient separation, continuous monitoring of the column effluent. It can be applied to the separation and analysis of very complex mixtures. Accurate quantitative measurements, adsorption, partition, ion exchange, and exclusion column separations are excellently made. Repetitive and reproducible analysis using the same column and not being restricted to volatile and thermally stable salts, and the choice of mobile and stationary phase is much wider in HPLC. Meanwhile,
The disadvantages of HPLC such as high costs, complex to operate, low sensitivity for some compounds, coelution is difficult to detect, and the irreversibly adsorbed compounds not detected. Thank you.